Hello, welcome to Math Discussion. Today's episode is about polynomials. What are they, and what are its characteristics? But before we proceed, let's talk about one of the most important unit in algebra, a term. A term is a single mathematical expression. What you see is an example of a term, yep. 2x. 2x is a term. It has a number part and a letter part. The number part is also called the coefficient, or a parameter. It could be a whole number, a negative number, or a fraction, and the letter part is called the variable, an indeterminate, or simply the unknown. It is arbitrary, and its value is not yet specified. It could have an exponent, a power, or a degree. It could also be inside a root, or become a denominator. A term could only involve a number. That is called a constant, and it could also contain just the letter, just a variable. Now let's proceed to polynomials. A polynomial is composed of terms. It could contain one or more terms connected by operators, the addition sign, and the subtraction sign. What you see is an example of a polynomial. It contains three terms, 9x raised to 4 minus 18x squared plus 9. Monomial contains a single term. Binomial contains two terms. Trinomial contains three terms. And multinomial contains many terms. It is commonly called a polynomial. Here are the characteristics to distinguish a polynomial from an algebraic expression. Number 1. It contains whole number as powers. Yep, a whole number could be 1, 2, 3, 5, 10, or 0. Yes, 0 is a whole number. Number 2. It contains no roots of a variable. Variables inside a cube root, as well as variables inside a square roots, is not allowed. Number 3. No fractional or negative powers on variables. Say for example, 2x raised to 1/2. Did you know that the exponent 1/2 is also equivalent to a square root of a number, or a variable? Also, a raised to -2 is not a polynomial. Number 4. No variables in the denominators as fractions. For example, 2 over x. This rational expression is not a polynomial. This also equates to number 3. No negative powers on variables. Did you know that 2 over x can also be written as 2x raised to -1? If it does not possess the characteristics mentioned, it is safe to say that it is just an expression, or an algebraic expression. One of the important things in polynomial is called the degree, also called the order. Look at the example. Some of the terms are missing. Imagine it is there, only that its coefficients are 0. If you can't see a degree, for example 4x, it is understood that the variable x has an exponent 1, only hidden. Raising a number, or a variable by 1, has no effect on the variable. You can determine a degree of a polynomial with a single indeterminate by looking at the term with the largest value of exponent in a variable. For example, x squared plus 4x plus 4. This polynomial is a second-degree polynomial, because the largest exponent is 2. And for a polynomial that uses different variables or indeterminates, just add all the exponents of the variables in each terms, and see which term has the bigger sum. The bigger sum is the degree of the polynomial. For example, 9a cubed bc squared plus 7a squared b. In the first term, 9a cubed bc squared, the sum of the exponents 3, 1, and 2 is 6. The other term 7a squared b has the sum of exponents 2 and 1 is 3. Therefore, the polynomial is in sixth degree. One unique feature of a polynomials is that, when you add polynomials, the result is also a polynomial. 3x plus 5x will result to 8x. 8x is still a polynomial. And if you multiply them, another polynomial will result. 3x times 5x is equal to 15x squared. But hey, do not divide polynomials. The result will not always be a polynomial. 3x divided by 5x squared. Canceling out the common variable from the numerator and the denominator is 3 over 5x. This is not a polynomial. In dealing with long-chain polynomials, it is convenient to work with them when we knew the standard form. To get the standard form, arrange all the terms in descending order of degrees, just be careful with the operations. For example, the given polynomial is arranged in a standard form. 7x raised to 4y plus 8x cubed plus 4x squared plus 5xz minus 6. Now, let's have some examples. Let's identify each if it is a polynomial or not. Number 1, 6. A polynomial. Number 2, 4x. Polynomial again. Number 3, negative 7x minus 5 9x. A polynomial. Number 4, 2xy. Check. Polynomial. Number 5, 3 over x plus 1. Nope, not a polynomial.